Have you ever looked up and wondered how those giant metal birds, airplanes, actually fly? For centuries, humans dreamed of soaring like birds. Today we can cross the globe in hours. But how do these massive machines get off the ground? It's not magic, it's science. We're about to uncover the secrets behind flight, from the forces that lift a plane to the technology that keeps it on course. We'll explore the engines, wings, and every part working together in perfect harmony. Whether you're a future pilot or just curious, this journey is for you. Buckle up. Let's dive into the world of aviation. We'll start on the ground, join the pilots in the cockpit, and follow a flight from takeoff to landing. Ready? Let's unravel the awesome science of how airplanes work. To truly understand how flight works, let's take a detailed tour of an airplane's main parts, moving from the very front all the way to the back. Each section of the aircraft has a unique job, and together, they make flight possible. The fuselage is the long, tube-shaped body of the airplane. It's the central structure that holds everything together. Inside, you'll find the passenger cabin, where people sit during the flight, and the cargo hold, where luggage and goods are stored. The fuselage must be strong enough to handle the forces of flight, yet light enough to be efficient. At the very front is the cockpit, which acts as the airplane's brain. Here, pilots use a complex array of instruments, screens, and controls to fly the plane, communicate with air traffic control, and monitor every system on board. The cockpit's design is all about safety and precision. The wings are perhaps the most iconic part of any airplane. They stretch out from the fuselage and have a special curved shape called an airfoil. This design is crucial because it manipulates the air flowing above and below the wing, creating the lift that allows the plane to rise into the sky. As the airplane speeds down the runway, the airfoil shape of the wings generates lift, which is the upward force that overcomes gravity and gets the plane off the ground. Without this clever design, flight would be impossible. Moving to the back, we find the tail section. The tail is made up of the vertical stabilizer and the horizontal stabilizers, which work together much like the feathers on an arrow. Their job is to keep the airplane balanced and stable, preventing unwanted pitching or yawing during flight. Attached to the tail are movable parts called the rudder and elevators. The rudder helps steer the plane left or right, while the elevators control the nose's up and down movement. Pilots use these controls to guide the airplane smoothly through the air. Under the wings, you'll usually find the jet engines. These powerful machines suck in huge amounts of air, mix it with fuel, and ignite it. The resulting explosion blasts hot gases out the back, creating a force called thrust that propels the airplane forward at incredible speeds. This is Newton's third law in action. For every action, there's an equal and opposite reaction. The backward blast of exhaust pushes the airplane forward, allowing it to accelerate down the runway and soar into the sky. Don't forget the landing gear, the wheels and struts that support the airplane on the ground. The landing gear extends for takeoff and landing, then retracts into the fuselage or wings to reduce drag while flying. Every part of the airplane, from the smallest bolt to the largest wing, is carefully engineered for maximum strength, minimum weight, and top-notch efficiency. Modern materials like aluminum alloys and carbon fiber help achieve this delicate balance. Now that we've explored each part, let's see how all these components work together in harmony as the airplane prepares for takeoff. The teamwork between structure, engines, and controls is what makes flight possible. Before takeoff, safety comes first. Pilots arrive early to check weather, plan routes, and inspect the plane for any issues. They walk around the aircraft, checking wings, tires, engines, and sensors. Ground crews load luggage, refuel, and balance the plane's weight. Too little fuel is dangerous. Too much makes the plane heavy. Precision is key. Inside, flight attendants check safety equipment and prepare the cabin. Passengers board, and everyone gets a safety briefing. Seatbelts, exits, oxygen masks. In the cockpit, pilots run final checklists and get clearance from air traffic control. Only when every check is complete does the plane push back from the gate. Every step is about making sure the flight is safe and ready. With all systems go, it's time to head to the runway. Let's see what happens next. The engines roar to life, vibrating through the cabin as the plane begins its powerful surge down the runway. This is the moment when physics and engineering come together in a spectacular display. Takeoff is not just about speed, it's about harnessing the forces of nature and technology to lift hundreds of tons of metal into the sky. As the aircraft accelerates, the wheels grip the tarmac, and the engines push the plane faster and faster. Air rushes over the wings, which are carefully designed with a curved top and a flatter bottom. This unique shape is crucial for what happens next. The faster the plane moves, the more air flows over the wings. The air on top travels farther and faster, creating lower pressure above the wing. Meanwhile, the slower-moving air beneath the wing creates higher pressure. This difference in pressure generates lift, the invisible force that allows the plane to rise. Inside the cockpit, pilots are focused and alert. They monitor every instrument, watching the speed build. At a precise moment known as rotation speed, the pilot gently pulls back on the controls, signaling the plane to leave the ground. The nose of the aircraft rises, and as lift overcomes gravity, the main wheels leave the runway. In just a few seconds, the plane transitions from rolling on the ground to soaring into the air. Once airborne, the landing gear retracts smoothly into the fuselage, reducing drag. The flaps, which were extended to provide extra lift at low speeds, are gradually adjusted for a more efficient climb. Pilots carefully manage the throttle and monitor the airspeed and altitude, ensuring the climb is steady and safe. Every adjustment is deliberate, balancing the forces acting on the aircraft. The engines continue to provide powerful thrust, propelling the plane upward. This thrust must be perfectly balanced with lift, weight, and drag to achieve a smooth ascent toward cruising altitude. Every move in the cockpit is calculated. Speed, angle, and engine power must work together in harmony. Pilots rely on their training and experience to make split-second decisions. Takeoff is a delicate dance of forces. Thrust, lift, weight, and drag all interact in a precise balance. Even small changes in wind or weather can affect the process, requiring constant attention. In a matter of seconds, the plane transitions from the solid ground to the open sky, leaving the runway far behind as it climbs higher and higher. As the climb continues, pilots adjust their course for weather conditions and coordinate with air traffic control, ensuring a safe path through the busy skies. Soon, the aircraft is soaring high above the clouds, where the air is thin and the view is breathtaking. The world below shrinks away and the journey truly begins. The science of flight is now fully in action, every principle of physics and engineering working together to keep the plane aloft. And with takeoff complete, the adventure in the sky has only just begun. Next, let's explore how pilots navigate the vast and ever-changing sky, guiding the aircraft safely to its destination. At cruising altitude, about 30,000 to 40,000 feet, the air is thin, reducing drag and saving fuel. Flying high also means smoother rides above most weather. Here, the four forces, lift, weight, thrust, and drag, are balanced. Pilots use GPS and inertial navigation systems to stay on course. No road signs in the sky. Autopilot handles routine flying, but pilots constantly monitor systems and communicate with air traffic control. Computer screens display maps and flight paths, keeping everything on track. The autopilot makes tiny adjustments, but pilots are always in command. Cruising is the longest, calmest part of the flight. Time to relax and enjoy the view. But soon, it's time to prepare for descent and landing. As the destination draws closer, pilots prepare for one of the most critical and delicate phases of flight, the descent. This stage is not just about losing altitude, it's a carefully orchestrated process that demands precision, coordination, and a deep understanding of the aircraft's behavior. Every action taken during descent is calculated to ensure a safe and comfortable arrival for everyone on board. To begin, engine power is gradually reduced, allowing the plane to start its controlled glide toward the airport. The aircraft follows a predetermined path, almost as if it's sliding down an invisible ramp in the sky, guided by both technology and the pilot's expertise. As the plane descends, pilots deploy flaps and slats on the wings. These devices increase lift at lower speeds, making it possible for the aircraft to fly slower without stalling. At the same time, they add drag, which helps slow the plane down in a controlled manner, preparing it for landing. Next, the landing gear is lowered. With a mechanical whir, the wheels extend and lock securely into place, ready to absorb the impact of touchdown and support the plane as it rolls along the runway. As the runway comes into view, pilots use visual cues and advanced navigation aids to align the aircraft perfectly with the center line. The Instrument Landing System, or ILS, sends out radio beams that guide the plane's approach, even in poor visibility or challenging weather. In the final seconds before landing, the pilot gently pulls back on the controls, raising the nose in a maneuver called the flare. This action reduces the rate of descent, allowing the main wheels to touch down softly. and ensuring a smooth, comfortable landing for passengers. The main landing gear makes contact with the runway first, absorbing the initial impact. Only after the plane has settled does the nose wheel gently lower, completing the landing sequence. Immediately after touchdown, spoilers on the wings deploy, disrupting lift and helping the plane stay firmly on the ground. Reverse thrust from the engines and powerful brakes work together to slow the aircraft safely, bringing it to a controlled stop. Throughout this entire process, pilots remain focused and alert, constantly monitoring instruments and communicating with air traffic control. Every step is managed with care, teamwork, and professionalism to ensure a safe arrival. The journey from sky to ground is a remarkable blend of human skill and advanced technology, a testament to the art and science of aviation. But what happens when things don't go as planned? How do pilots and technology work together to keep flights safe, even in the face of unexpected challenges? Let's find out. One of aviation's greatest safety tools is the black box, actually bright orange for visibility. There are two, the Flight Data Recorder, FDR, and Cockpit Voice Recorder, CVR. The FDR logs hundreds of flight details, speed, altitude, engine data, creating a digital history. The CVR records cockpit sounds and conversations, capturing every decision and alarm. These devices are nearly indestructible, built to survive crashes, fire, and deep water. If an accident occurs, investigators use the data to understand what happened and improve safety. The black box is a silent guardian helping make every flight safer. Its lessons shape new procedures and technology. Most passengers never see it, but it's vital to aviation's safety record. Now let's see how all these systems work together in flight. Flight is a symphony of science. Thrust, lift, weight, and drag in perfect balance. Pilots use control surfaces, ailerons, elevators, and rudder, to steer and stabilize the plane. Tiny adjustments keep the aircraft smooth and precise. Computers and autopilot monitor systems alerting pilots to any issues. Fly-by-wire technology translates pilot commands into electronic signals for safety and efficiency. Every part, from engines to navigation, plays a role in safe flight. Human skill and advanced technology work hand in hand. Pre-flight checks, aerodynamic design, and constant monitoring all contribute. Modern aviation is a marvel of teamwork and innovation. Each flight is a coordinated performance between people, machines, and the laws of physics. It's a testament to human ingenuity and our quest to conquer the skies. From takeoff to landing, flight is a triumph of science, design, and teamwork. Every part, from the wings to the black box, is the result of years of innovation. Flight connects people, cultures, and ideas, shrinking our world. Engineers keep pushing boundaries, making planes faster, safer, and greener. The story of aviation is still being written. Stay curious, keep asking questions, and look up at the sky with wonder. The science of flight is all around us, waiting to be explored. Maybe you'll help write the next chapter in aviation history. Until then, remember, every flight is a celebration of human achievement. Thanks for joining this journey into the science of flight.